Hello and welcome to the second chapter of the course, Main Theory Points. In this chapter, we look at the theoretical elements behind bounty tournaments. Our main focus will still be PSKOs, but we'll also talk about super knockouts, so the plain old knockout tournaments where you get a fixed value, and we'll also briefly mention mystery bounties. For more information on mystery bounties, feel free to look at the dedicated chapter. Now, one thing I want to preface everything with is that all the masters we're going to talk about were not made up by me. The work wasn't done by me. I merely studied it, I understood it, and then I'm presenting it in a more digestible manner, in a way where you can understand what I'm talking about and how it works without needing mathematical knowledge. If you, like me, are also not a math connoisseur, I guess. Another note is that if I use a term that you are not familiar with or you need some freshening up, then again, feel free to use the glossary at the end of the course, which will show you information about every single term I use, explain what it means, and that way you won't have any questions or misunderstandings. Finally, this presentation will be given to you with the course so that you can look at everything yourself. With that said, we can get started. And the main thing we need to concern ourselves with is how much is a bounty actually worth? Well, basically, it depends on the tournament type. It is very different in a progressive knockout and very different in a super knockout and different in a mystery bounty. It just really depends. The way we want to approach the spot is translate the amount of money that we are getting by knocking someone out into chips so that we can then understand how it affects our play, how it changes our pot odds, and how it interacts with our pre-flop ranges and also our post-flop strategies. In regular super knockout tournaments, it is worth half of a starting stack. I will explain more in the following chapter. So a super knockout is a tournament where, let's say, it's $100 buy-ins and $50 goes into the bounties, $50 goes into the regular prize pool, but the bounty amount is set and you just get $50 every time you knock someone out. So in that event, it is worth 50% of a starting stack throughout the tournament. In PKOs, it does not have a static value. A starting bounty's value changes over the course of the tournament. It starts at 25% of a starting stack at the beginning, and it can reach a maximum value of half a starting stack when heads up. Again, we're talking about a starting bounty. So in PKOs, a starting bounty doesn't have a starting value. In mystery bounty, it depends on when the mystery bounties come into play and the percentage of the field remaining in the tournament. So it would be different if, for example, mystery bounties come up when you get in the money. It's different if it's at 12% or 15% of the field left, if it's just when you reach day 2, where it might be 30% of the field left. These things just affect the value of the bounty a lot. As I said, regarding mystery bounties, you can just check the dedicated chapter at the end. Up next, we have some optional slides where we explain why a bounty is worth what it is. Like, what are the maths behind it? The reason that I'm saying this is optional is that it isn't that important for your game. You don't need to know why it's worth that. You need to know how much it's worth so that you can adjust accordingly. Knowing why it works like that, that's less of a thing, less of a concern. Just like the example I gave is you don't need to know how a microwave works in order to heat up your food, right? You don't need to know the science behind it. However, I will still explain it. So in SKOs, in super knockouts, which is where we're going to start from because PKOs is a different form of knockout, so we're starting from the basic one. One way to think about it is that since when you bust someone, you get back half the buy-in you paid, then a starting bounty is worth half a starting stack. For example, in a $1,000 buy-in SKO with a 10,000 cheap starting stack, if you knock someone out, you get $500, which is half your buy-in, so that is worth half the starting stack or 5,000 chips. However, this is a simplified way and sort of inaccurate to look at it. The real detailed solution involves calculating all the possible outcomes of a hand, figuring out the equity implications of a bounty, and then translating that into chips. So this sounds complicated, and I have an example in the next slide. But basically, as I said, it's worth about half a starting stack. So if it was a 10,000 chips starting stack, then when someone is all in and we cover him, it's as if there are 5,000 more chips in the pot for us to claim. So how do we calculate the outcomes of hand? How does that work? Well, again, it's best done with an example. So let's assume the $1,000 buy in SKO with 500 into the regular price pool and 500 into the bounty price pool with 10,000 chips starting stack. For this example, let's just assume that we're at the very first hand of the tournament. Small blind is 50, big blind is 100. We own the big blind, and the small blind just goes all in for 10,000 chips, so 100 big blinds. This is not something that will obviously happen very often, but for the case of the example, we just want a very simplified spot to examine. So first hand, we both have starting stack. Small blind goes all in for 10,000 chips, and we have the same stack in the big blind. So as I said, what we need to do is calculate the different outcomes of the hand. So what outcomes are there? Well, we call and we lose. The outcome of that is that our stack value is worth 0. From the 1,000 it was worth originally. It's worth 1,000 because that's just what we paid, right? We paid $1,000 to get 10,000 chips. So when we drop to 0, our stack value is now worth 0. If we call and win, our stack value is $2,500. Why? Well, because now our chips will be 20,000. We had 10, we doubled up, so we have 20,000 chips, which are worth $2,000. And then there is the 500 bounty that we got. So now we have $2,500 in value. If we call and tie, well, our stack is the same, nothing changed, right? Still, our stack value is 1,000. So if we fold, our stack value is $990, as we have 9,100 chips remaining since we just lost the big blind by folding. So now what we need to do is calculate the equity we need to call off by comparing the increase of our stacked value when we call and win by the decrease when we call and lose. So the value of our stack decreases when we call and lose by $990 as opposed to folding. So if we fold, we said our stack is worth $990. If we call and lose, it's worth 0. So we lose $990 compared to folding. So in order to figure out the equity then, what we need to do is divide the amount we lose, divide the decrease by how much it would be worth if we won, if we call and won. So this gives us an equity requirement of 39.6% to call in the Super Knockout tournament. Now, if the bounty element was eliminated, if this was just a normal vanilla tournament, the equity we would need would be 49.5%. And as a reminder, this is calculated by dividing the amount we need to call by the pot size. So 9,900 divided by 20,000, which gives us 49.5%. Therefore, the bounty element gives us an equity reduction of 9.9, because in a normal tournament, we would need 49.5% to call. In the bounty tournament, we need 39.6, so we need 9.9% less equity. How much is that worth in chips? What this means is that because we need less equity, it's as if we are being given better odds, as if there are more chips in the pot. So how many more chips are added in the pot by this bounty? And in order to calculate that, we have to reverse the procedure we did above in order to calculate the equity. So what we did is we divided the call amount by the pot size. So in this case, we know the call amount and the equity, but we don't know the pot size. So we know that the call amount is again 9,900. The equity is 39.6. And the pot size is X. We don't know that. So we need to solve this equation where we divide 9,100 by X, and this gives us 0.396. But this is simplified by then dividing 9,100 by 0.396, and this gives us 25,000 chips. We know that the pot was 20,000 before, so now with the bounty, the pot is 25,000. So there are 5,000 chips added to the pot, which confirms what I said before, that in a Super Knockout tournament, the bounty is worth half a starting stack. This does not change throughout the tournament. So this is the foundation for figuring out the value of the bounty in PKOs as well. So in A PKO tournament, for 50% PKOs, not like the special Saturday PokerStars things, we'll talk about those a bit later. So in a normal 50% PKO tournament, we follow the same thought process as before. We take the same example, 1,000 buy-in, 10,000 starting stack, and the same scenario as before. Small blind is 50, big blind is 100. First hand of the tournament, we have the same stack, and the small blind goes all in against us. So, what are the possible outcomes? Again, we call and lose, where our stack is worth 0. We call and win. Then our stack is worth 2,250. Because this is the 20,000 chips, which are worth 1,000. And then it's the 250 in bounty that we got. Remember, in PKOs, you don't get the full amount. You only get half of it, and the other half is added to your head. If we call and tie, our stack is worth, again, 1,000. And if we fold, our stack is worth 990, same as before. So now the equity we need to call is 990 divided by 2,250, as opposed to 2,500 from before, which gives us a 44% equity requirement. So now the equity requirement reduction is 5.5%. Because again, the requirement needed to call without the bounty is 49.5, same as before. And following the same procedure where we divide 9,900 by X, which equals 44% or 0.44, we found out that X is 22,500, which means 2,500 chips were added to the pot. So what this means is that we confirm indeed that in a normal PKO, a starting bounty is worth 25% of the starting stack. Not 1/3, not 50%, 25%. And this is figured out in the simplest way. We just calculate the different outcomes of the hand. For 75% PKOs, so this would be the PokerStars Saturday knockouts, for example, where 75% of the prize pool goes into the bounty prize pool and 25% in the regular prize pool. By following the same method as before, we reach the conclusion that the bounty is worth 37.5% of a starting stack. So, normal PKO, 25% of starting stack, 75% PKO, 37.5% of a starting stack. However, as we spoke about earlier, the value of a bounty in PKOs is dynamic and it changes over the course of the tournament. It doesn't stay at 25%. Why does this happen? Well, as we know, in bounty tournaments, the prize pool is split in two. It's the regular prize pool and then there is the bounty prize pool. In normal knockouts, the player field and bounty prize pool get reduced at the same rate. So in a super knockout, as we saw before, the bounty prize pool is reduced at the same speed. It doesn't get reduced faster or slower. In our 1,000 SKO example, if we assume a 100-player field, when there are half the players left, the remaining bounty prize pool will be 25,000. We will have 50 players left, each of them carrying a $500 bounty on their head. So we can see it's just an equal amount to the amount of players that have busted. However, in PKOs, that is not the case. In PKOs, because the bounties compile, you knock someone, you get half of his bounty and the other half goes on your head. So the bounties end up compiling. The field size gets reduced at a much faster rate than the bounty prize pool, because a very big portion of the bounty prize pool remains to be won at heads up. So this field size reduction leads to a fluctuation of the bounty value throughout the tournament. The bounty, as we said, is not static. It's not always worth 25%. So how does it change? Well, no two PKO tournaments are the same, as the percentage of the bounty prize pool that remains changes per tournament. But we can make some general conclusions and simplifications regarding the remaining player field percentage and the bounty prize pool. What I mean by this is that in a tournament, we can have one player busting everyone, or we can have each player busting one guy and then busting himself. This will give us different bounty prize pool percentages compared to field size. So we can make a very standard conclusion about this, but on average, some figures we need to keep in mind is that when there is about half of the field left, there is about 75% of the bounty prize pool in play. When there is 25% of the field left, there is about 56% of the bounty prize pool in play. When there is 12.5% of the field left, 42% of the bounty prize pool is in play. So this is very different to a super knockout tournament, where the percentage of the field and the bounty prize pool is just always going to be the same. In PKOs, we can see that the field gets reduced much, much quicker than the bounty prize pool. Again, this is because of the bounties compiling and piling up. I will say this again later, but I just want to clarify that this math is not done by me. I am not a math person. There was a lot of research done by this. What I'm doing is explaining it in a simpler way, but none of this is my work. I don't want to take any credit for it. It is just me rephrasing things and explaining it in a easier to digest manner. Okay, so we concluded that the bounty prize pool doesn't get reduced as quickly as people bust. So how does this affect the value of the bounty? In order to figure that out, we take the two extreme cases of our 100-person field tournament. The first case is that one person knocks out the other 98 and reaches heads up. Granted, this will never really happen in practice, but in order to figure out the extreme values of a PKO, we have to take an extreme case. So if one person knocks out the other 98 and reaches heads up, this allows for the maximum possible prize pool to reach heads up, about half of it. Because one person has accumulated all of the bounties, there is no money removed from the prize pool. So the biggest possible amount of the bounty prize pool has reached heads up. So what this does is it results in an unchanged bounty value of 25% of starting stack. Now, the other extreme case is that a player knocks out someone else and then gets immediately eliminated. This allows for the minimum possible prize pool to reach heads up. Because once someone knocks a player out, he removes a portion of the bounty prize pool from play. Therefore, when he's eliminating himself and then the person that eliminates him gets eliminated and so on, the minimum possible amount reaches heads up. And in this case, by following the previous procedure to figure out the value of a bounty, we reach the conclusion that it is worth 50% of starting stack. So the conclusion that we need to keep from all of this is that in a PKO, in a 50% PKO, the bounty is between 25% of a starting stack at the beginning of the tournament and 50% of a starting stack at the end of the tournament. In a 75% bounty PKO, the bounty is between 37.5 at the beginning and 120% of a starting stack at the end. Again, we are talking about the value of one starting bounty. So again, just to repeat, because this is super important, starting bounty in a 50% PKO, like the normal PKOs we play, is between 25% at the beginning and the maximum value it can reach is 50% at the end of the tournament when we reach heads up. Here we have some relevant, easy to remember figures for the value of a starting bounty as a percentage of the starting stack. These are approximations. The size of the field affects the value of the bounty. Not much, but it does affect it. And this is perhaps the most important and crucial piece of information we have so far. This is what we really need to know. Understanding why and the maths behind it and so on isn't very important, but knowing how much a starting bounty is worth at each stage of the tournament, this is what is very important. So we can see that at the beginning of the tournament, in a normal PKO, a starting bounty is worth 25% of the starting stack. When there is half the field left, it is worth about 29% of the starting stack. And when it's 5% of the field left, it's worth about 38% of the starting stack. In a 75% PKO, you can see the corresponding values, where again, it starts at 37.5, and then it heads up at 5%, it reaches 80%. Remember, the value in PKOs cannot exceed half of a starting stack, and in a 75% cannot exceed 120% of a starting stack. Again, we're talking about one starting bounty, how much it's worth in terms of a starting stack. Okay, so let's see a practical example. Let's take a 215 PKO, where $100 goes into the prize pool, 100 goes into the bounty prize pool, and $15 rake. Again, let's take a simplified scenario where we face a jump closing the action on the big blind in a 900 table at the start of the tournament. We both have the same starting stack, 5,000 chips, where the big blind is 100, small blind is 50, and the ante is 12.5. So in a normal tournament, non-bounty tournament, we would need 48.2% equity to call. we get that number by dividing the amount we need to call, 4,887.5, by the total pot, and this gives us the equity we need. So in a PKO, we need to add the bounty value, which is 25% of the starting stack, so 1,250 chips in the pot. And then by adding that into the equation, we realize that we need about 42.9% equity to call. So what we need to do then is adjust our calling range accordingly. Since we need less equity, we can call the all-in wider. And this is the process we should follow in game as well. We need to calculate a bounty, how much is it worth, turn it into chips, and then figure out how does it change the equity we need, and how does this affect our range. Next up, we have a helping method. Again, this was not created by me. I am simply rephrasing and introducing concepts that other people have done a lot of work on. So this is an easy way to approximate the equity reduction we need to call an all-in by using this formula. Now, me personally, I never really like this. I've never used this, but I know of a lot of people who find it helpful and use this instead. Again, this is just for figuring out how much less equity do we need to call an all-in. So in order to figure this out, we divide the number of starting bounties that someone has by the amount of starting stacks that someone has. So what this will give us is a number which corresponds to a percentage of equity reduction. For example, if we get a value of 0.5, this gives us an equity reduction of 3%. A value of 1, this gives us an equity reduction of 5.4. A value of 2 gives us an equity reduction of 9.3. A value of 2.5 gives us an equity reduction of about 11%, and goes on. So in the next slide, we will test this example. Let's look at the first example we had, where the all-in player was jamming 5,000 chips, a starting stack, and he had a starting bounty. So by using the formula, we divide the number of starting bounties he has, 1, by the number of starting stacks that he has, 1. And this gives us a value of 1, because dividing 1 by 1 is 1. Wow. So going back to the previous thing, we can see that a value of 1 gives us an equity reduction of 5.4%. So this just checks out extremely well, because as we saw in the previous example when we solved the spot, the equity reduction was indeed 5.3%. So story checks out. The same goes if we change the bounty slightly and we give the all-in player 1.5 starting bounties instead. So now 1,875 chips are added to the pot, and the equity would be found by dividing the call amount by the pot size, which is 40.6%. This gives us an equity reduction of 7.6%. Because again, compared to the previous example in a normal tournament, the equity would be 48.2% to call. Now, when he has 1.5 starting bounties, we need 40.6. So by using the formula, we divide the number of starting bounties he has, 1.5, by the number of starting stacks, 1, which gives us a value of 1.5, which corresponds to roughly a 7.4% equity drop, which is very, very close to the actual equity drop, which was 7.6. So this is as a helping method. It helps do things quicker. It's not 100% accurate, and it's not something I use, but it's there and it works. So it's up to you whether you want to be using it. Now, let's look at an example of how the PKO value increases. Again, let's go back to the original example where we had the player jamming 5,000 chips, the starting stack. But now let's assume that instead of it being at the beginning of the tournament, it's when there is 50% of the field remaining. So in this case, the starting bounty would be worth about 29% of a starting stack. So instead of adding 1,250 chips into the pot, we add 1,450 chips. Therefore, the equity we need to call is again found by dividing the call amount by the size of the pot, which is 42.1%, as opposed to the original 42.9 when it was the start of the tournament. So this looks insignificant, but it starts adding up as the bounties become bigger and there are more multiples of a starting bounty. So let's take this one step further. Let's assume that this 5,000 chips jam is done when there is 25% of the field remaining, and the all-in player has 4 starting bounties instead of 1. So in that case, a starting bounty would be worth about 32.5% of a starting stack. So 1,625 chips. So then the all-in player has, as we said, 4 starting bounties. Therefore, we have 6,500 chips added to the pot, because 4 times 1,625 is 6,500. And this makes the required equity to call 29.3%. So again, I want to bring your attention to this, that we need to know how much is a starting bounty worth at each stage of the tournament so that we can correctly calculate its value and figure out how it affects our strategy. Next up, we need to check out how do we use HRC to study PKOs. If we want to solve a pre-flop PKO spot, we should be using HRC. It is by far the most up-to-date and advanced software for studying PKO spots. HRC stands for Hold'em Resources Calculator. With its recent update, HRC has a built-in post-flop solver. So now it can accurately solve everything regarding pre-flop and not just all-in or fold situations. In the past, HRC couldn't tell you what the optimal action was. It could tell you whether a jam or a call was profitable. Now, because of the post-flop solver, it can actually tell you what the correct action is. Should we limp? Should we raise? What sizing? And so on. So in order to study and solve a spot, we need to take a screenshot or write down the information, but I would advise taking a screenshot, which shows the prize pool and the payouts, the amount of players left in the tournament out of the total amount of players, the bounties on the table, and if possible, the average stack or average bounty of the tournament. Some poker sites offer this information, some do not. If it's there, perfect, we'll get a more accurate result. If it's not, well, it's fine. Now, there are also two ways to solve a spot. One, where there is no ICM implications, so we're not anywhere close to the money bubble, late reg is still open, and so on. Then we can use a winner-takes-all format. In that way, we don't need to write down every single payout. So, for example, if it's a huge tournament with like thousands of runners that has just begun, well, writing every single payout spot would take a super long amount of time. So just inputting the entire bounty prize pool or regular prize pool as a winner-take-all, not the entire prize pool, just the regular prize pool as a winner-take-all, as a first-place prize, will give us very, very similar result because PKOs are generally super top-heavy and we are so far away from the money that it's just not going to be a problem. Again, this is only useful for spots very far away from any ICM. Now, I will show you how to use Hold'em resources to run a spot. So first, as we said, we need a screenshot. So for that, let's take this screenshot. This is a recent tournament of mine. And it is a spot where I have king, queen in the big blind. And I'm wondering, what should I do here? Should I call? Should I go all in? What should I do? We can notice that in the screenshot, I do have all of the necessary information. So I am showing the stack sizes. I'm showing the bounties. I'm showing the number of players left, the average stack, average bounty. This is a final table, so you can deduct a lot of that from the table itself. However, if it was, let's say, final 2 tables or final 3 tables, then we would need the lobby screenshot as well. Okay, so what do we do now? Well, we need to go to Monte Carlo hand, and we need to start filling in the information. We should start from the prizes, so the payouts. The first place would be this, then second place would be this, third place would be 85-7, then 6-3-7, and then 4-6-9-4. So now we have our payouts. We don't care about the people that have busted, we only care about the payouts remaining. If we were like 12 players left, then we would need to fill the payouts up until that point. Then we need to enable bounty mode. PKO. Now, for the stack sizes, what I do is I always set the big blind to 10, the small blind to 5, and then the ante to 1.25. This way, we can simplify the stacks to big blinds and not having to worry about the actual chip amount. HRC also offers you the ability to paste a hand history. So if you use Poker Tracker or Hold'em Manager or Hand to Note or whatever, you can copy-paste the whole hand history and click this button to paste it here. So the next thing we need to do is fill out the stack sizes. Since the big blind is 10, I will simplify all the stack sizes to something like that. So the guy opening would have 165, and Kane would have 172, Marjan would have 306, like a G6 would have 130, and I have 198. Note that I'm also accounting for the ante, so I always put like one ante more to each player. And now it's time to fill in the bounties. Now, for the bounties, we need to input the entire bounty amount and not just the amount we are seeing on the table. What does that mean? Well, what we are shown is the amount we are getting. So if we passed, let's say, Nkano, we're getting $1,325. That is not his whole bounty. That is the amount we're getting. So we're getting half his bounty. In order to solve the spot, as I said, we need to fill out the entire bounty that our opponents have and that we have, which is twice the amount that we see. This is for PokerStars. Other sites work a bit differently. For example, on Winamax, you see the full bounty on the table and not just the amount we're getting. What we need to write down is the full amount of the bounty, not just the amount we're getting. So Macoloke's bounty would be, as I said, twice the amount shown, which would be, let's see, so 3,732. Then Nkano would have 2,650. Marjan would have, let's see, how much is that? That is 1982. I want to say. Leica G6 has 2571. And I have 1622. This is easy. My amount is very easy. Let me just double check Marjan's that it makes sense. So 980 plus 980 would be 1960. And then, so no, it's 1972. Okay, there we go. So now we have the stacks, we have the bounties, we have the payouts, we have everything done here. We need to make sure that the hand mode is set to Monte Carlo, and the equity mode is on final table ICM, so Marmoth Farvel ICM. If this was with multiple tables left, then we would need to do multi-table ICM, and in the next tab, we would need to fill out the amount of players and what the average stack size would be for them. So if it was, for example, say 20 players and the average stack size would be 30 blinds, then this would need to be like this. We can also change the average bounty if we have this information and edit out everything here so that it's accurate. In our example, we are on the actual final table. So we click next, and then we get to the post-flop settings. We need correct post-flop settings in order for HRC to properly calculate our decision. So first we have the sizings. Here we should use the sizings allowed. So that would be 2x, which he used, and then also we want to give him an all-in option. Same goes for the button. The small blind giving him a 2.5x open and all-in. Big blind, the same. Now, if there are limps, we also want to allow the option to increase the open size when there are limpers. So for example, from the button, we would need to say 2x and then say plus 1x. So what this means is that the opening size is 2x and then one more for every limper. One more blind for every limper. If we don't have limps allowed, then this doesn't really matter. But if we want to run a spot with limps allowed, then we should have this enabled. Then we need to set the 3-bet numbers. So how big do we want in position to 3-bet? In this case, 2.5x plus 1x for each caller is correct. And then the all-in option. This seems correct as well. So big blind, 3-betting versus other positions. Yep, I think this sizing also seems correct. Small blind versus other positions, it doesn't really matter because his only sizing will be all-in at this stack size. Here we can also set the 4-bet sizings. We should usually change that, especially when we are deeper stacked, because 90% in position of 4-bet is usually going to be an all-in. So we want to use something smaller, like say 2.2x or something similar. It doesn't matter for our example because everyone is short, but overall, this should be set to something other than 90%. Now, we set the number of limps or the amount of players that can call. So for limps in this spot, we want to have 0. The small blind isn't included in this. It is just people if we want to allow them to limp or not. We will look at some limping spots later on in the course. For now, this is just set to 0. Opens is basically the amount of players that can call and open. So we should go for something like 3. 3 bets, 4 bets, yeah, should be 1. We don't really expect more people to be cold calling 3 bets. Then we need to allow the small blind to complete. We need to enable cold calls, so this is allowing people to call the open, and everything else here seems appropriate. Then we need to go into post-flop. So for post-flop, we want to allow a small c-bet sizing besides the geometric one. In terms of raising, just using a small raise size is correct, 40%. And for c-bets, it doesn't really matter, just the small one as we said. Donking, limited for, again, small sizing, and we're good. We don't need those to be super accurate as long as there is an option for a small sizing and a big sizing. That is going to be well enough. The final thing we need to do is make sure our turn and river flops are also at least 1,000. The more flops you have, the more accurate results you will get. I would advise going for at least 1,000. At least. If it's a smaller spot or a quicker sim, you should go for more, but at least 1,000. Then we click finish, and one mistake that we make is to assume that we are now done. We are not. This is just the setup of the tree, and now we need to actually run the hand. So what we need to do is click on the green play button over here, and we have 2 choices. One would be to run the full tree, and one is to run the selected subtree. So if we run the full tree, then every action will be solved. We usually do not care about that. We just want to look into the subset that we are interested in. So this example, it is when out of the gun raises. It is this subset. So we need to click selected subtree. We should run until CI value is reached. So CI value is something like the accuracy percentage in PyroSolver. We usually want this to be below 5 for a decently accurate result. The simpler our decision is, for example, let's say blind versus blind jump, the lower of a CI we should go. Going for something like 5 is enough, and we should reset regret. Then by clicking OK, the sim actually starts running. We are being shown the speed at which it's running, and also at times we'll show the average time, the expected time remaining until it has reached the desired CI. As the sim is running, the actions will change, and the mixes will round up, and we'll get to a pretty good result. Now, a few more notes. One would be the settings at the top right. The first setting just shows us the AV, whereas the fourth setting, which is the one I usually use, just shows us the actions in color form. So we can see which hands want to raise, and so on. Then we can explore the tree and see the different decision points. Of course, I didn't allow this to run enough to get accurate results. This is just to highlight how we should use the software. One final functionality of HRC that I want to mention is showing us the bubble factors. We'll talk about risk premium a bit further later on, but it does get to show you the risk premium of each player against each player. If you are not aware of risk premium, you can have a look at the glossary, but basically it means how much more or less equity does a player need in order to call the other players all in. Usually when you cover, your RP will be slightly negative, especially if the opponent's bounty is big. And if you are not covered, of course, it will be a negative risk premium because of ICM pressure on the final table. In a non-ICM hand, our risk premium will always be negative when we cover, and it will be at 0 when we are covered because nothing changes for us. I will also want to highlight the winner-take-all scenario that I spoke about earlier. So let's take this tournament example. But instead of being at the spot we are, which is on the final table, let's assume we're at the start with like 500 players left. Well, in that case, we don't really want to write down all these payouts. It just takes way too much time. So instead, what we want to do is, okay, so I said, let's assume that it has 500 players. So if it has 500 players at the beginning of the tournament, then this would give it a prize pool of 150,000. We want to use half of that, so 75,000, as a winner-take-all, and then fill the table stack size accordingly. Everything else stays the same, and this will give us almost identical results as filling out the entire payout structure. Again, this is only to be used when we're talking about a spot very far away from the money at the beginning of the tournament to save us time. It is not something we should do when we are deep in the tournament. or close to a bubble spot. One functionality of HRC that was recently added is the ability to export a sim into PioSolver and then solve from there. I also would like to illustrate that. So let's move on to the next slide. This is done by importing the saved HRC output of the action we want to examine, and then we input our usual parameters on PioSolver. It is new. It is not entirely confirmed by secondary software whether the bounty element is properly represented in the risk premium model. What I mean by that is that the way this post-flop solver works is that it takes the negative risk premium and positive risk premiums into account and gives us a post-flop strategy. A way to think about it is that if you cover someone, it's kind of like you have negative risk premium, so it's as if you're the big chip leader in a final table and the other guy has to play a bit tighter against you. So again, it's not exactly clear whether this is very clearly represented and this is very accurate, but it is the best we have and what we have to go with for now. One final note is that we need to keep in mind the software limitations with them not accounting for future EV. We will touch on this topic in a few slides, but basically, sometimes some spots we want to deviate on and not go for the solver optimal play, simply because the solver doesn't take into account what happens in the future. If we double up and then cover everyone, we'll have a lot more EV. If we end up losing half our stack and cover no one, that will hurt our future EV a lot, and so on. So, on to the example of how we solve the hand on PioSolver. We're back to the HRC sim and we select the node we want to solve. So for example, let's say hijack calls and hijack opens and then big blind calls. So we want to click on big blind calling. Then we want to go into hand and then we want to go into export selected node to Pio. Then we just get to save this as whatever we want. This will take a few seconds to save. And then by opening PioSolver, we want to go into tools, and then we import the ICM model from HRC. This new window will open up, and then we want to click open, and then we want to select whatever file we want. This will immediately input all of the settings from the HRC file, the stack sizes, the payouts, the risk premium, everything. So then by clicking OK, we have all the settings, all the ICM settings added here. What is left for us to do is simply fill out the board we want, and then fill out our usual bet sizes and raise sizes. And then PioSolver will solve the spot for us. So this is the new development in PKOs that we didn't have in the past. HRC can solve for every pre-flop spot, and PioSolver can solve the post-flop spots. Next up, we have some factors that we need to consider outside theory. I briefly touched on that a few minutes ago, but basically, covering people on the table or not covering them affects our EV by quite a bit. Since the prize pool is split in two, the regular and the bounty prize pool, having access to the bounty prize pool by covering people is very beneficial for our stack's EV. So some things we need to consider is, what does our stack look like and who do we cover if we win a pot? Let's say if we win an all-in situation. What does our stack look like and who do we cover if we lose? Can we still fight for bounties or will we be left very short? How does this affect our future EV? Are there any soft spots on the table? For example, let's say there is a guy with 2 big blinds left who will be on the big blind next hand and he folds. Well, in that case, we should try and avoid marginal spots in that hand because we want to be able to fight for his bounty when he's auto-in in the big blind next hand. Then also, we should think about all these factors from our opponent's point of view. So how likely is our opponent to get it in wide against us? Is he incentivized to do that? Does he want to gamble with us? Or is he more incentivized to play tight because he covers a lot of people now and doesn't want to lose, and so on? Of course, there are many more factors. These aren't the only ones. But I want to pinpoint that this is only for marginal spots. We shouldn't make any massive deviation from theory or go for super tight folds or super aggressive call downs. You know what I mean? Wide call downs, I guess. Because these are all very minor things. Our adjustments should be minor, and we should only take these things into consideration when we have a marginal spot where the APs will be very close. Now, let's talk ICM. On final tables, our risk premium in a PKO tournament is about half of what it would be in a normal vanilla freeze-out kind of tournament. The reason for this is that the prize pool is split in two. We have the regular prize pool and the bounty prize pool. So risk premium in ICM only applies for the regular part of the prize pool. Therefore, it is about half in PKOs. So what this means is that our ICM pressure is much lower, so we are allowed to stack up wider, defend wider, raise wider, and so on. However, again, we need to keep in mind that this works the other way around too. We need to see this from our opponent's perspective. For example, when we're a short stack and we are considering going all in, what we need to think about is that, yes, our ICM pressure is lower, but also our fold equity is much lower as well because of our bounty. Our opponents are incentivized to get it in wider against us. The same goes if we are the big stack. Yes, we cover our opponents with the bounty, but their ICM pressure is lower, so they can stack up wider than in a normal tournament. So we should be a bit more careful. Basically, it's important to think about these concepts from both sides of the argument, not just the one that fits us. So overall, on ICM related spots, we want to re-steal jam less as the short stack, and we want to be open jamming less as the chip leader because, again, people call wider because they have less ICM pressure. And we get to RFI and defend wider ranges. We will see many practical ICM examples later on in the course. This is just about the theoretical part. Also worth noting is that some PKOs have the same payout for first and second place, and some do not. The risk premium and the ICM difference between these two are negligible. It's almost the same thing. Both are super top heavy, so this difference between first and second place doesn't really affect how we should play final tables. It does affect it when we are three-handed, of course, or like four-handed, but not at the beginning of the final table. Speaking of ICM, let's talk about bubble ICM as well. So bubble ICM in PKOs is quite peculiar. We established that risk premium in ICM is much lower in PKOs, about half. However, what happens is that very often we end up having to play much tighter as the short stack on the bubble, because even though the ICM pressure on us is lower, so we don't mind busting that much, our fold equity is also significantly lower, which results in our all-ins getting called way more often. So it is very, very common that we just end up having to play tighter in a PKO bubble than a normal bubble when we are short stack, regardless of our risk premium being lower. So it is very important for us to be able to visualize the differences in calling ranges when we jump between vanilla and PKO when deciding on whether we should go for a jam as the short stack. It is also significant, though, to weigh the risk of busting against the benefit of doubling up and covering more people. Again, this would be more so for marginal spots, especially in tournaments with a smaller field count. So at times, it will be fine for us to take a very marginal bubble spot if that means that by doubling up, we end up covering a lot of people and can therefore claim a lot of their bounties. Finally, we have some general points and some closing thoughts. It's very, very important to pay attention to the table. This is imperative. It is of the highest importance. We need to be able to spot the short stacks with the big bounties, and we need to be aware of table dynamics, especially during series or big field tournaments where we play against more unknown regulars or recreationals, because their perception of bounties will be different. As I said, it is a bit of an unexplored territory, so people still think maybe a bounty is worth half a starting stack. Maybe they don't convert it to blinds at all, or chips. They just see a number and decide if they want to gamble or not. So figuring out how do our opponents perceive the bounty, how much they gamble for bounties, is really, really important, especially when we play against people we don't know. It's also very important to not miss opens or VPAPs or limps or calls or whatever because we haven't seen a very short stack. For example, let's say the big blinds auto-limp because we just lost a pot last hand. We need to be aware of that. Also important to mark the hands we are unsure about and then solve them using HRC and BioSolver. Another thing that a lot of people struggle with is being sort of afraid to get it in with a bad-looking hand and looking stupid. It is the nature of PKOs that they at times just kill our win rate because we end up having to call an all-in with Queen 4 offsuit. That's fine. When we get the odds to make these kind of calls, we should just go ahead and make them. And yes, we will mostly lose, but that's fine. That's how it's supposed to work. So it is very important to not be concerned about looking bad or being afraid to gamble. The final and appreciated point is that the main way, the best way to improve at PKOs is just repetition. You mark hands, you run them again and again and again until it becomes sort of second nature. Every PKO spot will be different from the other. There is no set rule that we can follow. The reason for that is that our decision not only depends on the stage of the tournament, as it usually does, it depends on our bounty, our opponent's bounties, our opponent's stack size, our stack size, just so many factors that are different every time. So because of that, there is just no specific strategy that we can follow, and every spot will be a bit different from the other one. So what we can do is run sim after sim after sim after sim so that we see as many spots as we can, and we can compare spots we face in game with spots we've solved in the past. And with that, we can close the theory chapter. Hopefully, I explained things through in a satisfying manner. And now we can move on to common scenarios that we face when playing. Again, even though there is no two exact same PKO spots, there are recurring scenarios that happen very, very often. And these are the ones that we will try to look at and find some common ground and some common patterns we should try to follow.